facilities for emergency room care, the administration of anesthesia, and life-saving surgical procedures, just to name a few. SOPs are put into place in many areas in healthcare to save people's lives, and yet when it comes to fire stopping or passive fire protection, a life safety component designed to protect the lives of the very people whose lives were just saved, there often is no plan in place. This webinar will outline the benefits of having this most important life safety feature, and our presenter today is Kelly Mason, Director of Healthcare Partnerships at STI. Kelly, the floor is yours.
Thanks, John. Thanks, Christina. I want to welcome everyone to the webinar today. We're going to talk a little bit today about what a standard operating practice in terms of fire stop should look like in a healthcare environment. As John said, there are many different SOPs in place in healthcare, but typically not with fire stopping and the managing of life safety barriers. So some of the ideas and best practices we're going to show you today could be an idea for you to use in one of your facilities or maybe in the design phase of the facility. So a standard operating practice, in essence, looks like this. A full overview as to what is expected of anyone working in that rated barrier. That way, all expectations are clear. In my opinion, it should be a part of the bid document. So if a project is awarded, the standard operating practice should be a part of that. And it explains those procedural requirements, what's expected of them in their performance. Obviously, submittals are very, very important. We're going to talk about that. Sometimes submittals are overlooked and when we're dealing with rated barriers, penetrations, joints, and those kinds of things. Installation requirements, very important. And then any architectural specifications. If you have a architectural presence for a project, an SOP should be a part of that. And again, failure to meet the SOC would result in contract termination. So what would happen when someone is going to follow the SOP or start a project within a facility? They would obtain the most current version of that SOP, and these should be updated on a regular basis. Obtain prints detailing hourly rated construction, identify the scope of the fire stop work, obviously obtain manufacturer's product application information, any penetrating permit that may be in place for your SOP, schedule a training class for individuals to meet a level of certification to show that they can perform the work, prepare itemized schedule of penetrations, basically the work that's going to be performed, identify what UL assemblies are going to be utilized for each one of those. What you're going to find today is we're going to get into the testing process, what an actual UL system should look like. It's not Red Caulk fixes everything. And then submit those schedule of penetrations with those drawings, EJs if needed. We'll talk a little bit about engineering judgments and your train certifications. Questions for consideration. Is there an established protocol for managing fire stop compliance? As a as a facility manager or a design consultant, if a client in that healthcare arena needs that type of protocol, STI can help you with that. Is there a barrier management process in place? Now, the SOP is part of what a true barrier management program should look like. We'll touch on some of that today. Do either of these processes force accountability? Accountability is huge. If there's some sort of oversight in the process, then we can ensure the work is probably done correctly. Is there a complete understanding of what is expected? Obviously, that's what the SOP will bring home. So when we're trying to seal penetrations and joints through fire-rated assemblies, especially in the healthcare environment, this is what is expected. And what you're seeing here are photographs of applications that have been done correctly. All too often, this is what we find we get. And it's a misunderstanding. No expectation is made clear, and those that may be performing that work don't have a full understanding of what's expected and why it's expected. So the three key principles of a balanced fire stop or fire protection process. Obviously, early detection is very important. We want to make sure that all those things are working correctly. Active suppression, another very important part of an active balanced fire protection program. What we're talking about today is compartmentation or containment. We want to make sure that the fire and smoke stay in the compartment in which it is started. These buildings are, designed to provide safe zones throughout the facility. Obviously, we're dealing with defending in place. We know it's not practical to be able to get patients out of a hospital facility in a timely fashion. So these fire-rated assemblies, floors, walls, and all the components within them are tested to a certain hourly rating. And we want to make sure that the products, specifically today, that deal with Firestop applications are the right products that meet the right applications moving forward. Simply put, fire stopping is the process of sealing openings around penetrations or joints to restore the ratings back to their original rating. And we're going to take you through a couple of, I think that it's important to note how these things are tested so that you can get a better idea of what a manufacturer may go through to ensure that these products meet those requirements. Now, when we talk about the codes, the IBC, the NEC, the IPB, the IMC, and the NFPA, they all talk about having a third-party tested assembly to bring back the integrity of that rated barrier. The code, the sentences may be a little different, but basically the message is the same. So in the IBC, when we talk about the 2015 edition, through penetrations are in section 714.312. Through penetrations for fire-resistant rated floors, ceilings, assemblies, or ceiling members of the roof ceiling assembly is 714.412. And then for joints is in 715.1. We also will talk a little bit about exterior curtain wall applications too. Now, in terms of a facility director running a facility on a daily basis, curtain wall doesn't come into play very often. But in the design and build of the new project, curtain wall can be a very critical part, and the requirements there are vast. So we want to talk a little bit about that today. So where do you fire stop? Obviously, when you have your life safety drawings, these barriers all have some sort of a rating. Typically, a concrete floor will be 2 hour, with very little exception. And walls can be anywhere from a 1 to a 4 hour. We even have smoke wall applications. These walls should be identified in your life safety drawings. If you're not sure and you're looking at a barrier that you think is rated, it doesn't hurt to seal it. It will not do anything but help the application. But seal it with something that is made for the type of penetration and the hourly rating that you believe you're working with there. Three main types of Firestop systems. We're going to talk about penetrations, probably by far the most common. We'll talk about through penetrations, as well as maybe we'll touch on membrane, where you only have a penetration coming out of one side of the wall or the other. Joints, we'll talk a little bit about how you deal with that. It's a completely different test standard and a different product line, and we'll dive into that a little bit. We'll touch a little bit about your perimeter fire containment applications, typically for a curtain wall. So when we're trying to find a UL assembly that meets the requirement of what we have penetrating through the wall, we're trying to achieve a couple of things. One thing is the F rating, and that's deemed the fire rating, the time period that the through penetration Firestop system limits the spread of fire through the penetration when tested in accordance with this standard that you see, ASTM E14 UL 1479. All manufacturers have to test to the standard. I'll dive into a little bit of what that looks like today, but all manufacturers are required to meet those assemblies. We also are looking for T ratings. The temperature of insulation rating, the time it takes for a single point on the non-fire side to reach 325 above ambient. What we start to find there is that the radiant heat off of those penetrations, for instance, a metal pipe passing through a wall, if we have a fire raging on one side of the wall and the pipe is getting hot enough to get that 325 above ambient, then we could have a combustion there. So we want to see how fast that happens and publish that. This gives you, through the IBC, I'm sorry, Firestop in floors for IBC, for through penetration Firestop systems. The T rating, there are a few exceptions to that, And we'll talk about that. For floor penetrations contained and located within the cavity of the wall, the T rating being an equal rating to the F rating. If it's inside the cavity of the wall, we don't have to have that. On the other hand, if we have floor drains, tub drains, and those kinds of things contained and located within the concealed space of the horizontal assembly, they also are exempt from that T rating. And then floor penetrations, a maximum of 4-inch, penetrating directly into metal enclosed electrical power boxes. So if you see the picture on the left where you have penetrations running up through the floor, and that thermal rating, if this were outside of that application, would need to be equal to the F rating. So consider a metallic pipe passing up through a floor. And let's say it's a 2-hour floor. It'd be very hard to reach a 2-hour T rating on the opposite side of that because that metal conducts that heat. So there are, again, those exceptions are if it's within the wall cavity or within a chase, then you're exempt from that. You can see in the top right-hand corner, we talked about the floor drains. And then at the bottom right, you can see those pipes are actually going right into a box. So those are the only exceptions for an equal T rating. In most cases, you don't find a lot of penetrations up through the floor that aren't in these types of conditions, but they're out there, and we want to make sure that we know about them. How do we test for that? So what you're looking at here is a lab situation where we're doing an actual burn test. And as you can see, the white pucks that are on the top of that plywood deck, those are thermocouples that are going to measure that temperature to see how fast we get to that 325 above ambient. This shows a very good picture of a UL assembly, and you can see the magnitude of what you have to do if you do have a penetration passing through a rated floor assembly that is required to have an equal T rating. You can see it's just not red sealant, right? So that thermal wrap that goes around that, our product is called E-Wrap. You can see that you're going to go 3 feet above the floor assembly and 12 inches below in order to hold that heat back long enough to meet that 2-hour rating. So there's a lot more to it than just putting some red caulk around that opening. We also test for L ratings, and L ratings are for your smoke applications. What we're looking for is 5 cubic feet per minute, CFMs, per opening, or a total of 50 CMs for any 100 square feet of wall or floor. So think about that. It's not just penetrations that you're measuring. You may be measuring plug boxes in the walls. You may be measuring the cracks around the doors. You have to have an aggregate of no more than 50 square CFMs for 100 square feet of wall space. The W rating. Obviously, we want to, in some applications, we want to know what the W rating will look like. Quantifiable measures resistance of a Firestop product to water in the building. And how we test that is 3 feet of head pressure is applied to the seal for 72 hours to determine if the seal is watertight. And it's intended to address washout. A lot of these products are meant to be cured. Some of them are water soluble. You got to be very careful if you're in an area where you think water may intrude. Maybe consider a building that's being built. The roof deck is not completed yet, but curtain walls are going up, and we're starting to treat the joint. You need to make sure the product that's being utilized there will withstand that W rating. So IBC reference test standards, we already talked a little bit about this. For through penetrations, for an ASTM is E814 and UL is 1479, joints E1966 and 2079, and then the curtain wall testing applications for the ASTM standard is 2307 E119. There is more than, I've mentioned the term UL multiple times today. UL is probably one of the most common labs that test for fire stopping applications, but there are others. And these tests are typically acceptable. They are Intertech and FM Global. So let's show you what that ASTM standard test process looks like. So once again, we have a concrete deck here. You can see the black pucks on top. We're measuring that thermal, that T rating. We want to see how fast we reach that 325 above ambient. Those thermocouples will measure that. You can see the penetrations coming up through the floor assembly, various types. On the bottom, obviously we're testing PVC this day. you can see that we have various types of PVC applications. And what you see around those PVC pipes are collars. And collars are loaded with intumescence, which means an expanding product. At certain temperatures, these products will start to expand. And as the PVC is starting to melt and burn away, this product will close off that opening. Why is it so important to have that collar there? That metal conducts that heat. The PVC doesn't conduct enough heat to be able to activate the intumescence. So the collar is very, very important in these types of applications. So you got to be very careful. If you start seeing PVC pipes in large sizes with just intumescent sealant, there's no system for that. So you need to make sure that the assembly matches the test that is being applied. This shows a picture of the furnace, the burn furnace at UL. You can see there is an assembly bolted to the top of it. Could be a floor, could be a wall application. The time temperature curve is very strategic. And as you can see, at 5 minutes, we want to be at 1,000 degrees. In real world scenario, if there were a fire in the building, the room is going to be toast at that point at 1,000 to 1,700 degrees. But depending on the hourly rating, takes us to a different temperature evaluation. So at 1 hour, we want to be at 1,700, 2 hours, 1,850, and so on and so forth up to 4 hours. Now, this is a requirement by all manufacturers to meet this actual application. So very important part, tough test for sure, but you have to meet this requirement to be able to start the process of getting a UL assembly. This shows a concrete floor assembly being brought off of the furnace. And a couple of things to note here. You see the back left-hand corner, that large pipe. If you were to look above that, it's hard to see in the photograph, but it had a rubber insulation around it, like an Armaflex or something like that. And you see the one in the left-hand corner with the white ASJ, that would be a typical water pipe or something like that, a fiberglass jacketed insulation on top. Both of those are burned away at the bottom. So the fire was not able to pass through and burn the insulation away at the top. Very important to note. On the back right-hand corner, you see a collar where the pipe is missing. The collar is activated and shut that down. But the biggest thing right here that jumps out at you, obviously, is the flame. And that is a bundle of cable. Now, cables are probably one of the most intense and toughest to test because they continue to burn. You pull the flame away from them and they continue to add BTUs to the actual penetration. So cables, we'll talk a little bit more about that in a second. But what we're trying to achieve here is not let that flame pass through to the other side of that barrier. Then we get into what's called the hose stream test. And the hose stream test, in my opinion, is probably one of the toughest to pass. And you can see there is a designated process for how the hose test is run. The pipe has to be, the hose has to be a certain size with a certain size tip. There is you have to be so many feet away from the actual penetration, and then you're actually blowing the wall out and trying to blow the penetrating product or the intumescent or Firestop product out from around the opening. And if you're able to achieve that with the fire hose, then we fail the test. So it's a very, very critical part of the UL assembly and the ASTM standard. So we keep talking about systems. So what are some of the things that you need to identify in order to get to pick a proper system? There's a lot of variables here. You know, the variables look like this: the assembly type, the hole size. The hole size in regards to what's the distance around that penetration. We call it the annular space. And if you exceed a specific annular space per the UL test, then you have to go find another system for that. Now, I'm not saying that UL systems make you have an exact measurement. There typically is wiggle room when we're dealing with angular space around pipe. It may say something like from point of contact up to 2 inches. Point of contact being pipe touching on one side of the opening or up to 2 inches. If you exceed that, then the system would have to be changed. The penetration type, is it insulated? Is it cable bundle? Is it just standard metallic pipe? The Firestop product would be based on those first 3 applications. In some cases, it may be an intumescent sealant like you see in the picture, because what you're dealing with there is just simply a metallic pipe through a drywall assembly, probably one of the more easier applications to deal with. But if it's insulated or it's cable bundle or the annular space size is excessive, then we would have to go back and find maybe a different product or an addition of products to make that work. And then obviously your system rating. Are we dealing with a 1 hour, 2 hour, or up to a 4 hour? This gives you a shot of what a typical UL assembly would look like after this. Obviously, WL 1222 has been achieved. You can see at the very top, it says the hourly rating, the arrow pointing to the F rating. This is for a 1 or a 2 hour. And it will designate in number 1, where it says type of barrier, what designates a 1 hour or a 2 hour rating. So this particular system would cover that type of pipe through a 1 hour or 2 hour based on the substrate itself and how it's built. The type of penetration, you can see in number 2, through penetration, the metallic pipe passing through, and then minimum maximum annular space. I talked about that. This particular system says, like what I was talking about, 0 point of contact to a maximum of 2 inch. So you've got a little bit of wiggle room there. And then based on meeting that requirement, you can see at the bottom, it would tell you what Firestop materials are allowed to be utilized there. So if any of that were to change, maybe that's a block wall instead of a drywall assembly. Maybe that's an insulated pipe instead of a metallic pipe, or PVC pipe for that matter. Those things are going to change the process and the system that you go look for. So these are evidence of compliance. It's kind of a color by numbers. If you meet those requirements or you're within those boundaries, then these are a set of build instructions for you to be able to utilize. So many types of applications. We talked a little bit about cable management, like you see in the top right-hand corner. The thing about cables is that we find that there's a lot of moves, adds, and changes associated with cables. So it's a constant requirement to have to go in and re-enter that. Curtain wall, as you see in the top left-hand, curtain wall, a lot of variables there too, actually. So are we dealing with an aluminum? Are we dealing with box mullions, eye mullions? Or what is the spandrel panel, which is the distance between glass? Typically, the decorative band you see around the building, is it brick? Is it glass? What are we dealing with there? They all react differently to fire, so there's a lot of variables there. You see in the bottom left the joints application. We're going to talk a little bit about joints in a second, but it is a completely different product typically from what we use around penetrations. And all too often I see penetration type applications being used at joints. You just want to make sure that the product that you chose there will meet the requirements for movement. Very important part, because typically joints are made to move, and we'll talk a little bit more about that. And then down in the bottom right-hand corner, a lot of variables when we're talking about mechanical, electrical, and plumbing and sprinkler. The MEPs are vast, and you can see in a couple of those pictures there, we may have a situation where we have one opening with multiple products passing through one opening. Now, those are achievable. We call them super systems, and we have a lot to choose from there. But again, there are requirements that have to be met within those types of systems. So the assembly must meet the application. I think I've said that enough today. So we're going to talk a little bit about a submittal packet. So if I'm a facility director, or I am a general contractor or an architect working on a new project, I'm going to want evidence of what UL systems are going to be used to bring back the integrity of rated barriers as we penetrate through them. So a series of drawings that meet each type of application would be submitted and approved. Now, if you're a facility director, all too often when I ask the question, are you receiving a submittal based on work that's going to be performed in your hospital that doesn't have anything to really do with a new tower going up? It could just be remediation, or maybe you've gone through an inspection and have to do some repair. You need to have that evidence of compliance. So submittal should have the following: manufacturer's product information, safety data sheets, and these are all readily available for all products. UL tested system drawings, very important. If there's an engineering judgment is simply that. If you have a system, if you have a penetration through a wall assembly and you cannot find a UL tested assembly to meet that requirement, and it could be for various reasons, then you're going to want to call the manufacturer and talk to the engineering department, and so we can put together an engineering judgment based on like penetrations or UL assemblies that have been tested prior, so that you've got some sort of evidence of compliance of what needs to be done there. Manufacturer's installation product procedures for each product, and approved applicator certificates. Again, you remember I talked earlier about your SOP. You should have anyone that's ever going to get above a ceiling tile or touch a barrier in your facility should have a level of certification for dealing with those types of applications. So what to consider, some considerations in the design phase. A couple of things you need to think about. Some things you're going to fire stop once and you're never going to touch them again. But some things maybe not so much. Decisions on what best fits the facility today may create elevated costs tomorrow. And I'm thinking about cable penetrations probably more than anything when I'm thinking about that. There's a cheap, fast way to fire stop if you have a cable bundle passing through a floor assembly or a wall assembly, and it's in a sleeve, and it meets the code. It meets code in terms of cable load requirement, and you're just absolutely sure that no one is ever going to run another cable through that. Then we have tests for conventional methods like sealant or putty. I don't necessarily condone sealant, even though we do have systems as well as other manufacturers, because if for some reason you do have to re-enter, that means someone's chipping away at that product to dig it out, and it could be running a heart monitor right down the hallway. So there may be other considerations, but if you're convinced that you're never going to look at that again, then that may work for you. On the other hand, if it's an area that's going to be high traffic, that would be a terrible decision. And we'll talk a little bit about that. How often will penetration in a barrier be re-entered? How will you monitor, or who will monitor these penetrations after the re-entry? So in the SOP, there would be some level of inspection that would be utilized for those types of penetrations. What parameters have been put into place to eliminate those repairs later? So in terms of what to consider in the design phase for insulated pipes, insulated pipes react a little differently than obviously a metallic pipe. Insulation is combustible, it will burn away. You need to make sure that the system that has been chosen for that application will meet the thickness and type of insulation that's being used there. And again, you have to take into consideration angular space requirements like we talked about before. That doesn't change, but as long as you can meet those requirements, there are lots of systems that will address insulated pipe. Sleeved cable penetrations. I talked a little bit about things to consider. What types of cables will be used in these sleeves? Very important. Will there be a need for reentry? That's the big question there. If you feel like someone is probably going to reenter there, then you want to, take note of that and make sure that the system you pick will allow for that easily. A non-hardening putty should be considered. As you can see in the picture, this particular penetration putty is being used around this penetration, or the cable bundle. Now, there's actually two penetrations here. You have the sleeve passing through the wall, and then you have the cables passing through the sleeve. Now, at the wall, using a sealant there, because the sleeve will probably never be removed, is a good choice. And the system will call for that. But, where you may be, there may be a re-enterable application desired, putty would probably be a good start, especially for small applications. Putty, it remains pliable. You can pull it out of the opening, roll it up, set it on the ladder top, discard cable or put cable back in, roll up the putty and put it back in its place. Highly intumescent. You just want to make sure that the putty that you choose will remain pliable. There are some putties out there that have a clay base, and they will start to harden over time. So you want to make sure that, decisions that you need to make based on, the applications you're dealing with. Excuse me. Sealant would not be a good application here for the cable bundles, and we talked a little bit about that for sure. We also want to make sure that we understand that there is a limitation in terms of cable load, and we'll talk a little bit more about that too. Large openings. Most manufacturers make some sort of a pillow type product. The great thing about the pillow is it can be friction fit into the opening. It covers a large area and they can be stacked. So in theory, you could pull that pillow out, run new cable, put another conduit in, put the pillow back. Highly intumescent. Our pillows are intumescent on all sides, so they expand in all directions. So in a fire in this particular application, that would completely swell and open and fill all voids and eliminate any smoke and fire to pass through that. Now, what we're talking about in essence is high traffic openings. So reentrability is an important part. You want no requirement for removal of product if you can keep from doing that. Typically what we find in the field, if somebody's going to have to remove product and put product back or react to the manipulation of the sleeve, then we're probably going to have some failures in the field. No requirement for sleeve alteration, no requirement for cable load worries. Can the device be retrofit to existing cables? Important to know. Are they gangable? So you could increase your capacity in a very small area. Allows for easy moves, adds, and changes. Basically a sustainable design for years to come. So let's talk a little bit about that overloading situation with cable bundles. So I mentioned a couple of times that you got to be very careful about overloading of cables in a sleeve application. Now I'm talking about conventional methods here. Conventional methods being a sealant or putty in a sleeve. The UL system will tell you what your allowable capacity is that we've been able to do to pass that test. I can tell you that the largest test using conventional methods is 49%. 49% cable load, and that's an STI system. What you're going to find across the board is anywhere between 30 and 49% being the STI system. So how many, think about in your facility, if you're a facility person, how many sleeved openings do you have that are 100% full? I would guess that there's probably some out there. And if you're the designer and you're looking at these types of applications, you have to take into account, what will my 5-year plan be? What will my 10-year plan be? Should we go ahead and plan for that now? Remember, I talked about what you do today may cost you later. This would be a good time to maybe cut your cost. Now, because of the influx of these types of applications, STI being a Firestop manufacturer, we are asked over and over and over again over the years, how do we deal with this overloaded sleeve? Well, before this product came out, we would say you're going to have to pull the sleeve out and increase the hole size, or you're going to have to remove cable. Both of those are very cost prohibitive. So we started to work on, how could we take an overloaded sleeve and make it compliant once again? This is called the retrofit device. And if you see the picture on the left, obviously 100% full. I don't care how much red, sealant, or putty you try to get in that opening, you cannot achieve a rating. The product on the right actually attaches, it's a clamshell design, attaches right to the sleeve. If the sleeve is not protruding from the wall far enough, then there are slits in the side of the retrofit device where we can attach a fastener that would actually attach it right to the wall assembly. As a matter of fact, we have systems where you don't need a sleeve at all. Maybe it's just a cable bundle passing through the wall assembly. So something to keep in mind and consider when you're dealing with maybe overfilled capacity. This system is meant to handle 50% to 100% cable fill. You don't want to put these on the wall if there's no cable there. This is a fix-it product for those applications that are overloaded. This is how you fix moving, from the start. The Easy Path product, there are multiple manufacturers that make different types of applications that will allow for 100% cable fill. The biggest difference here is that this product doesn't require any manipulation of the product to make it work. It can be completely empty or completely full, doesn't matter. So it takes all that guesswork out. There's no requirement of installing any product in the openings either. So it is smoke, fire, compliant, and you can see multiple sizes. It's gangable. Remember, I said there are a couple of things you want to consider. The picture on the right where you see all that optical fiber raceway passing through the sleeve, there is no UL assembly out there that will allow you to do that other than this product line. it's because of the intumescence. It's all throughout all throughout the sleeve itself. Normally, they're going to want you to break those up. So running multiples, future design, if you're thinking that your capacity is going to be at this level, then you add a couple so that over time they can remain empty and they're still compliant. The person that's going back in and running cable can simply just put the cable through the opening. Now, another great part of what the EasyPath process offers is an evaluation service report that was issued in 2016 by UL for EasyPath fire-rated pathways. And it confirms code compliance with the International Building Code, the IFC, and the NFPA Life Safety Code. The report goes on to confirm that when properly installed, EasyPath pathways are exempt from the ongoing maintenance process. Take that into consideration too. Talk about saving cost over time. This product can really help you in that aspect as well. A lot of variables to what this product can do. Verticals, horizontals, gang together, floor applications, wall applications, non-rated applications. We'll talk a little bit about that. As you can see, a lot of variables here. A great cable management process for facilities. Now let's talk a little bit about floor cable penetrations. Now, when we're dealing with data communication closets and the like, typically if you go into a facility and you go to a data communication closet and you open the door and you look at the wall right inside the door there typically is maybe 4, 5, 10, 4-inch sleeves going through the floor assembly. That is typically where I go to look when we're in a facility, and you can tell right away if you have an issue with overloaded cable penetrations. And also, there's not a lot of space in these data communication closets. So if I could find a way to combine multiple sleeves into one and not have to worry about overloading, that would probably be a product that I would want to utilize. So along the same lines of what the EasyPath does in the wall assemblies, the floor grid assembly, and you can see multiple aspects of how it can be utilized here. And if you see in the top right-hand corner, you can see that you can just drop in a module. So over time, if you decided that you're thinking over the next 10 years, I'm going to go from 1,000 cables to 10,000 cables, then you could plan accordingly and just have a blank over that module opening. And as your capacity increases, you pull the blank off, slide a new module in place. And obviously, the real estate inside those data communication closets are at a premium. And this could eliminate, because of the 100% cable fill, the use of multiple sleeves that would be needed if you were following the code requirement for cable load. Great application. Now, for non-rated applications, we're still trying to seal walls sometimes for other reasons. Maybe it's smoke, maybe it's acoustics, maybe it's just a clean way to be able to manage cable passing through non-rated walls as well. We do make this version here. The NES is what we call it, non-rated EasyPath. We make it in blue for walls and white for ceiling tiles. Some of the older facilities still have ceiling tiles they use as a smoke-rated assembly, and that white product can be utilized there, as you see here. I've been in many facilities where we walk into a data closet and the facility director is going to pull his hair out because he sees that someone has either destroyed his ceiling tile or tried to put red sealant all around it. So those of you that have had that happen in your facility, you know what I'm talking about. This product simply attaches to a unistrut, attaches right to the wall assembly, and it is flush mounted to the top of the ceiling. And, aesthetically pleasing because it's the color of the ceiling tile grid. So great product for that. Another product that is fairly new in the industry, this is called our E-Wrap. I showed you some of this when we were dealing with the T-rating application outside of the chase wall. The great thing about this product, especially when we're dealing right now, there's a lot of emergency responder communication system, ERCs, that are being put in facilities, and anything above a certain height, you have to maintain a 2-hour survivability. How do you do that? You either put that in some sort of shaft or it's encased in concrete. Both are costly. This is a simple wrap product, and it also includes fire pump applications, signaling equipment, elevators, alarms, process control equipment. We're even doing fuel oil piping as well now. We have a brand new approval in the state of New York where this product can be used for fuel oil lines too. So keep that in mind, especially in the design side of things. This can take a lot of cost out of a project. Head of wall designs. Basically what happens at the head of the wall is a mineral wool or some sort of a high temperature insulation is placed in the wall, in the flute of the deck or above the wall assembly, and then spray is applied over the top of that, or a caulk. This product actually attaches right to the top track. It is an intumescent gasket, and it's then attached to the wall assembly. It eliminates any requirement for sealant or spray. Again, huge labor saver. It's a one touch, typically on the ground, and done. Cast in place devices. These have become very popular. These obviously have the fire stopping within the sleeve already, and they're poured right into the concrete pour. Keep these in mind as well. Cast in place devices come in a multitude of sizes and depths for different types of pipe applications. And in the proper setup, this can be a huge labor saver. Also, think about in new facilities where maybe you have a tower rising next to a pre-existing tower, and the vibration of coring openings, the noise, the vibration could affect convalescence of patients in the other tower. It might be a wise choice to go with a cast-in-place device. Curtain wall, we talked a little bit about some of the different variables here. We do have a specialist in this field. His name is Eric LaCroix. Pay close attention to the STI website. He does webinars like this on a regular basis and talks about all the different variables and types of curtain wall applications. We'll have one coming up here very soon. Specifications. STI has written specifications for all types of services. So not only do we have a general spec for Division 7, which is typically where the Firestop specification is located, we find it prudent to have an actual Firestop spec for each sub-trade. So we have one written for the mechanical spec section, the electrical spec section, data, joints, perimeter, all of that divided out so that a contractor can't say, well, I didn't know I was supposed to do it that way. I thought it was his job, those kinds of things. A good specification, a well-written specification, again, makes those expectations very clear. So we have these readily available on our website, and we're glad to share those with you. We can also do a review of your specification. We do this on a regular basis. Some of the specifications around Firestop are old and antiquated. There are manufacturers in some of these specs that aren't even in business any longer. So allow STI to maybe take a look at that for you. It's a service we provide for free. Along that line, if a facility is being built using building information modeling, we also have the objects for BIM for your application. For penetrations, joints, curtain wall, and smoke and acoustical. We also have a Firestop clash management tool. It's part of the Revit toolbar, which is probably the most important part of this. So you're not having to download and upload to another site. This can be part of your Revit bar. You just have to allow the interaction. If you're asking for clash management and the mechanical contractor says, I have 510-inch pipe passing through 2-hour rated drywall assembly, by employing this application, it will give you all of the UL systems, and you can apply the objects to the drawing as well. Very, very cool tool. And by the way, did I say this is free? No charge to you. Great product. Now, we talked a little bit about barrier management program. The SOP is a part of the barrier management program. Just real quick, best practice. STI has developed a barrier management program that's very popular. Some of the largest healthcare systems and facilities in the world are using our barrier management program and using that SOP as part of that. It's a managerial approach to Firestop, a lot of support systems, specialized support. Firestop is our only business. So we take a lot of pride in that. Technical support, training is critical. And the training that we have designed around our barrier management program for facilities is second to none. It is That particular system, it does require a test. And again, in an SOP, I want to make sure the people that are working in my rated barriers, because we are dealing with life safety applications, well, I want to make sure that they understand what they're supposed to be doing. That training is not a product sell. That training is technology. It's UL system testing. It's all of that. Proper UL system selection and inspection. We can help you with that too under a barrier management program. Just STI alone has more than 1,500 UL assemblies. That can be a daunting task to be able to select the right systems. So STI can build a select breadth of systems for your facility, which may amount to maybe less than 50. And that would be utilized for each individual contractor. So if I'm an electrician, I'm handed that package and I say to him, these are the systems you're allowed to use in my facility. Now, if you see something in the field that is not covered within the packet, we can always add that. But we're going to cover 99.9% of what's being done there. And then we utilize products engineered where we know we're going to have reentrability. We want to use them everywhere, but we know those areas. Joint movement capabilities. If we know that we've got joints, we do not want to be using intumescent sealant that does not have a memory in those applications. Our acoustics, of value, et cetera, et cetera. Simply put, a set of standards as to who, what, where, when, and how, and why Firestop is being done or inspected. This can also be a very useful tool for a specialty Firestop contractor who wants to be a part of the solution of the barrier management in healthcare. A lot of facilities, a lot of projects use a specialty Firestop contractor, and that may be your best choice. A contractor that specializes in the application of fire stopping products may be your best bet, and something that we could obviously talk to you about. So we want to survey. This is how it would go. You would survey and identify what action is needed. Basically, I'm giving you the roadmap of how you go to C-suite and ask for the money. Adopt a standard operating practice. Determine how to fund the repairs. Arrange certified Firestop training. You can do that through any of our STI personnel. Conduct random destructive inspections just to make sure accountability is there, and document all the progress. Why do we do something like this? Obviously, to meet regulatory compliance, ensure those installations are proper per the code, stop annual outlay of capital, exhibit a proactive approach for inspection, prevent property loss, and end of the day, life safety is what it's all about. So, since 1990, the leading global provider in Firestop applications. Our Firestop training we talked about, that fit level 1 that I talked about, these are the bullet points of what will come up in that actual presentation, that certification training. We'll talk about Firestop fundamentals, containment, fire-rated construction, UL systems, parameters and testing, proper product selection, types of Firestop applications that are out there, penetrations, high traffic, construction joints, proper installations, and myths about Firestop. Now, that fit level certification, obviously right now, is being done virtually. We can bring that to your facility. We can give that to you virtually, or you can go to our STI website and you could go to Firestop University and select that type of training there as well. And the great thing about it is you can take it at your own pace, and once completed, get a certification there. The engineering support I talked about. If we're dealing with engineering judgments and those kinds of things, we want to make sure that you fully understand how to achieve that. It's a simple process by going on our website. We actually have a live chat function for that as well. System search. This is an application that is on our website. We also have a website for that, an app for that. I'm going to take you to that right now. Give me just a second. We'll go back to that. The system search will allow you, based on simple questions, maybe you don't understand exactly what system you need. You can go on the website, you can go to system search, and it will ask you a couple of simple questions. Again, if you're still stumped, you can go to that chat function in the bottom right-hand corner, and you will have a live fire protection engineer from STI ready to discuss that with you. And these are the pretty faces of those people that are behind the scenes there of our engineering department. Now, if you go to our website, to be able to achieve all these great tools I've been talking about, you'll go in the top right-hand corner and you'll see Access STI. I'm going to give everyone a moment to maybe take your cell phone, download that UR code, excuse me, and give you a chance to log in and create your own password for Access STI. Many of the tools that I showed you, plus many more, are available on the Access STI website. So I'll give you just a second. Okay, this concludes the AIA portion of this presentation, but I wanted to take a short minute to show you a couple of things that have come out. One, due to the COVID pandemic, a new product that may be able to help facilities and design going forward. So obviously the new reality of hospital life, we're trying to conserve PPE, minimize needing to enter the room on a routine task, maintain the ability to change medication. So what many hospitals have done, they've started to run cables under the door. Obviously, we're just trying to, mitigate the face-to-face contact between clinician and maybe infected patient. I know that you still need to get in there and see those people, but there may be some touches that you could maybe utilize by just going and monitoring the equipment itself. Here's another shot where we're showing the same kind of thing, and this is a very common, problem that we're starting to see, and we know there's been an uptick recently again in regards to the pandemic. So how do you do that and not create a trip hazard and a real problem? For trying to get cables and tubes under doors. This product is called the CPAD. It's the Clinician Patient Access Device. And as you can see, it provides a portal that goes into the corridor application. By the way, this application meets all code requirements for fire rating where needed, acoustics. It is a sealed device, much along the lines of maybe what our EasyPath product looked like. The best thing about this is it's a flush mounted design, doesn't get into ADA requirements, and when not in use, it blends right into the wall assembly. The color coordination is common with most corridor type colors. Two-part application comes apart, can be applied in the wall assembly, and once installed in the wall, then you can move all that equipment away from the door through the wall assembly and still be able to monitor from afar. And then lastly, the new product, EasyPath cable tray retrofit device. I showed you the retrofit device for sleeve penetrations when we're trying to achieve overloading, that kind of thing. So we've designed one for cable tray applications too. The biggest problem with large cable tray designs is there's a lot of moves, adds, and changes that happen there. And when product is being pulled out and put back, it's not always put back in an orderly fashion. You can apply this around a pre-existing cable tray device, and once that's in place, you just run your cable in and out of it. Great product. You can probably think of where those may be in your facility right now. Consider maybe using the retrofit device for cable tray. We are a worldwide, global company with offices, as you see, all around the world. I wanted to just give you real quick a quote from our president. At STI, products are but one component of our value package. As a fully focused manufacturer, we are committed to providing complete solutions to your Firestop needs and challenges. We remain committed to these values, our client partnerships, and the Firestop industry. And that's by Charbel Tager, our president for STI. Again, any of the things that you saw today, we have installation videos of everything that you saw today as well. You can reach them at stifirestop.com. Again, use that Access STI and dial into some more tools as well. Anyone can reach me at kmason@stifirestop.com. If you have any questions, concerns, or maybe want to schedule something, discussion, please reach out to me. I guess we're time for questions, John and Christina.
That's right. Thank you so much, Kelly. Great job. You did an awesome job as usual. Everyone out there, we have another QR code. We love QR codes here at STI. So if you want to hit this QR code, that'll take you over to a LinkedIn post for Kelly here. If you could give him some feedback, we love giving some prizes away. We have some bags, some OGO backpacks, some Carhartt tool bags and things like that. So if you go ahead and leave him some feedback, we'll pick a couple winners there. Kelly, we're going to get into some questions. We had a couple come in here. We have 2 on the board. Maybe some people will type in as we ask these, but I'll get started with this first one. With no fire in a building, what is the installation life of an intumescent sealant? Should fire stopping be replaced over time? Is any maintenance required over time? It was kind of like a 3-parter. So take your pick, Kelly.
Well, intumescent applications are typically used around combustible penetrations for the most part. The red sealant that you typically see around a penetration, that intumescent product will start to expand at around 350 degrees is the typical application. And it can be used on combustible pipe all the way up to multiple sizes of insulated pipe and even some PVCs based on size of PVC. In terms of replacement, the products do not need to be replaced as long as they have not, obviously there's been no fire in the building. What you may want to do over time is make sure and go back and see if I've seen penetrations where maybe a cable contractor has just dug out a small area around one of those penetrations, run cable through it, and not put anything back. So just being able to look at those, but you shouldn't have to replace them unless they've been destructed.
All right. Christina, you want to take the next one there?
Yeah, sure. And just to touch on that maintenance too, all of our product data sheets on our website have if there is maintenance required, have it listed on the product data sheet as well. The next question we have, do you need to fire stop behind the easy path setup to seal, or is it good once you close it?
So the easy path itself, the internal workings of the sleeve does not require any fire stopping whatsoever. Now, the actual kit comes with a collar that goes around the easy path, and it has an intumescent gasket that's part of that design. So you can use, if you're buying the kit application or multi-gang application, there's no red fire stop that would be used there, no intumescent sealant. You would typically be using a gasket around that collar.
Yeah, Kelly, and don't put the intumescent sealant in the easy path.
No, never. I've seen it. People misunderstand.
We've all seen it. All right, we have one more question up here for now. Will the C-pad maintain a positive pressure environment for a hospital room?
So the C-pad is tested much like, any type of penetration. I talked about, you probably have much bigger fish to fry when you're worried about that. Maybe the crack around the door, the plug boxes, and those kind of things. The pressure differential with that product is probably better than most of those things.
Okay. So there you have it. Seeing no other question. Oh, wait. Really good presentation, Kelly. You're getting some feedback. That wasn't a question. That was a comment. But thank you, Selena, for that. Kelly, great job. We appreciate everyone attending. Christina, you just want to give the housekeeping again for everyone who wants their certificates?
Yeah, we'll be reporting AIA for those of you who gave your AIA number. We'll report that for you. If you didn't give your AIA number, you can, when you register, just send it to webinars@stifirestop.com, and we'll be sending certificates as well as the recording in 7 to 10 business days.
All right. Thanks again, Kelly. Thank you, everyone, for attending. Stay safe out there.
Have a good one. Thanks, everyone.